Hello, I'm Philip. Welcome back to the CLICK programming tutorial, video number 8. This shows up as CLICK 8 on the descriptor. On the last video, we got to just starting to use variables instead of constants for timers and counters. But I need to really take you into the next deeper level, which is pointer addressing. The example that they show you in the software manual doesn't give you a real understanding of how to use it and when to use it. So I wanted to make sure I gave you a really good example because it's a very, very powerful tool to really help on programming, especially when you get into more complex programming. So if you're liking these videos, please subscribe and don't forget to give me a thumbs up. In the last video, click number 7, we began talking about using a variable in timers and counters instead of the constant. That gives us a lot more flexibility. For example, this timer was set at 30 seconds before. If we wanted to change that timer to allow more cars to come through, say to 40 seconds, then we would have to come back up to the write project into PLC, which stops the PLC, which means no red lights, no lights working at all, just to be able to change the timer. But by having this variable in here, this single data word number 1, then we go back to here, we can see that single data word number 1 was a stoplight timer adjust. So we can just write to this value, this memory location. We can put the value in that we want through the data view, for example, right here. We can come in as we were doing here. We can write directly into this value right here and change that. Also, we could change it from maybe a touch screen display that's connected to the system, or if there's a remote location like we talked about, this is a city and they've got a remote location for monitoring all the red lights and the stop lights in the city, then they can also change it there remotely, and that would work very well and very easily as well. So with that, that was our first introduction to using memory variables. And also we said that the memory variables, one of the good things about them was, we'll go back over the example here, is they are read and write, the R and W right here. We can read from that value anytime, and we can write to that value anytime, so we could change it on the fly, so to speak. So I want to take it to the next level. I want to take it to pointer addressing, or indexed addressing, or indirect addressing, whatever you want to call it from your background. But with the CLICK PLC, they call it pointer addressing. So I'm going to change to a project that I was just starting to do, and I'm going to go to the function tab, go down to the software manual, and you can see here, let's see, I'm going to put in a pointer address, list topics, there's pointer addressing here. Here is what they show you for the example for pointer addressing. Now this part here is difficult to see, so what I've done is I've already taken that and put it into our program so we can look at it and view a little bit closer in. This tells you how to set up the address. You can use any memory variable location just about, and you can see the list of them right here. And in there you can stick a value instead of a constant value like 100 or 32 or something. You can tell it, no, it's going to be whatever value we have in this location, which is data single word 100. Now this only works with a data single word for the address that it has to pick from. The example here is you can copy whatever's in this memory location and put it into this memory location. So here we're taking the value that's in double data word, and which data word is it? It's the one that's whatever the value is in DS100. So if DS100 was actually a 32, then this would be double data word 32, and we're going to take that and we're going to put it in this location, which is double data word and whatever the value is in DS101, which could be 200, for example. So then it would take the value that's in this double data word 30 something up here and put it in double data word 200 down here. And the other thing is, when you're doing the pointer addressing and you're doing the copy command, it will only copy one memory location to another memory location at a time. So if you had 30 or 40 different memory locations that you were going to copy from and to, you'd have to repeat this that many times to be able to fill that new destination memory block. So I'm going to take a look at the examples that they've given you here. Let's go back out of this. Now this is an always on bit. You can see it's an SC, so therefore it's a system bit. It's always on, so it's the same thing as if I just do a delete right here. It's exactly the same thing, because it means it's always allowing the flow to come through. So we're always, every scan, every time we come back through on our scans, we're going to be putting 100 into DS1 and 200 into DS2. So I'll take this one back out. I'm going to put it back in. You'll see the text up here. This, if I right click on anywhere on this rung number 1, right click anywhere there, I can say edit rung comments. So I can type in whatever I want here and it will stay with that rung. Comments here is initializing the source pointer to 100, initialize destination pointer to 200. So this DS1 becomes the source pointer, and DS2 becomes the destination pointer. Let me come back up into the address picker and I'll type those in very, very quickly here. You can see I've already got some other stuff in. That's for a little bit later in the program here. So this one we said was going to be source pointer. And this one's going to be destination pointer. Oops. Okay. So now we have these in here. So going down to rung number 2. Rung number 2 is a for statement. And a for statement is something we haven't talked about before. It's a loop. The beginning of the loop is the for statement. The end of the loop is the next statement. So the for statement always works with the next statement. And you can see the for statement is the beginning of the loop. It's on rung 2. Then there's rung 3. But the next is on rung 4. So what it means is it's going to do rung 2. Then it's going to do rung 3. It's going to come down and check rung 4. Nope, you're not at 100 yet. Comes back up. It does number 3 again, comes back and checks number 4. Nope, you're not there yet. So it continues to do rung number 3 until we've reached the total count that's required by the for statement. So in this example, they're saying they want this to continue for 100 times. This always on bit is just like what we saw earlier. If I delete that, it's the same thing as not even being there. What are we doing? We're doing a copy. We're copying from bit DS1, and we know the DS1 is up here was 100, is what we've got in there. So it's copying from this address C100, and it's putting it into C DS2. Well, DS2 is 200. So now it's copying what's in C100, and it's copying that into C200. The next part of the command is it's taking DS1 and it's adding 1 to it. This is a math statement. This is the result where we're putting our answer in. And this is what we're doing. We're saying whatever the value is in DS1, which remember we started at 100, we're adding 1 to it, and then we're storing that result back into itself, into DS1. Then we're doing the same thing down here on DS2. Exactly the same thing. So this one was 200, and now we're going to add 1 to it, store it back into itself, and it becomes 201. So we're going to say OK. So then every time it does this, it's incrementing. So the next time it comes back to start rung number 3 again, it's going to look at the value in C101, and it's going to place it into C201. Then it's going to increment to DS1 and DS2 again, come back up again, and it's going to put C102 into C202. And this will repeat for 100 times. And then the next is complete, and then we go to the end statement. At the end statement, the scan returns back around to 1, and it starts over again. So these values now, DS1 had incremented all the way up to 200, and DS2 had incremented all the way up to 300 because we continued to add 1 to it for 100 times. So this initialization, when we start the program back over on rung number 1, then it puts a 100 back in this one and a 200 back in this one and starts the whole process over again. So let's see what happens when we write this down into the right project into the PLC. Now our monitor is turned on now. You can see the values. Here you can see DS1, we're putting 100 into it, but it's always showing up as 200. And the reason for that is it's staying there the majority of the time. We're just getting a glimpse up to the computer from the PLC, because you have to remember this has a pretty fast scan time. But when we talk about scan times, because it has to take this and do this 100 times, that really slows the whole process down. So now when it gets down to number 5 on the rungs, comes back up to number 1, then it has to slow down and do this for 100 times and come back. So our scan time, if I come back here and I look at the online project information, then I can see that the PLC status is good. There's no errors or anything like that in there. I can see how much memory I've got left, which is quite a bit. But what's really important here is look at the scan time. We're currently running about 47, 46 milliseconds. That's pretty long. If you remember when we first did our first program, we looked at the scan times and we were in the order of 3, 4, maybe 5 milliseconds. But now we're all the way up to 47 milliseconds, at least 45 and a maximum of 48. That's showing our range that we've got. But the reason for that is because we're doing this 100 times. What if we change this value to 50? Okay, now because this is not a variable, it's a constant, we have to go back in and write the project down into the PLC. So now when you come up here, you can see these are 150 and 250, because now we're starting off at 100 and we're doing it 50 times. So come back up to the information. Let's get the scan times. You can see it cut our scan times down, 24, 25. 24 is the fastest, 27 is the slowest scan time that we've had, but our scan time changes depending on how much work we have to do. Now the work is done by, it has to process each command all the way through as it goes through. Once it goes through, ends up at the end, comes back around, starts off on rung number 1 again. That scan time is what it looks at. This is kind of a poor example, and the reason it's a poor example is you don't see the reason for it. So therefore, I've started setting up something else over here to show you guys. Go back into Address Picker. We're going to make believe we have a machine called a loom. Okay? And not only that, we have 4 of these and they're all connected to the same PLC. All 4 machines are identical. The information that we have from each one is total yards, what the RPM is, what the shift downtime is, the shift efficiency, and the product code of whatever it is that they're making. Starts on at DS20, and then I will come down again. DS40, I'm showing the information for loom number 2. DS60, I'm showing the information for loom number 3. And DS80, I'm showing the information for loom number 4. Now, this is where the informations are stored at, but I've got a display, a screen display, and that display, I can only see one machine at a time. I want my display software to be simple. So I just want to know, instead of an address pointer, let's call this a loom number. And that's the loom number that we want right there. And the destination pointer for the offset. We want to be able to see this information all the time on the loom, and all we have to do is just select from the display. We want to see loom 1, 2, 3, or 4, and those values will always show up in the same location here. We don't have to go hunt for them anywhere else. So what we want to do is we want to use the pointer addressing to point to this new location, and then use a for next loop to bring that data up into here, so that whenever we're on that particular screen or that particular machine, we see the correct data for that machine in this location right here. So I'm going to write a new little for next loop just for that. So if you'll give me a few minutes here, let me break away, and I'll do that and I'll come back. All right, I'm back. That didn't take long. Let me start off with the program section. You may have noticed earlier I had a little bit of extra data in there, and I told you it was for something later. Well, this is it. I've added in these nicknames so that it makes it easier for us to look at and see what we're doing. The DS1, notice also everything I'm doing here is with DS. They're single integers, single word integers. So I'm starting off, the first is the loom number. And we said we have 4 looms, so they could be 1, 2, 3, or 4. And the old loom number, because what I want to do is when I check to see if we have a new loom number, I'm going to check to see if it equals what we had before, the old loom number. If not, I'm going to say, hey, it's time to update the data. And then the pointer offset, and I'll show you how that's going to work. And then the destination where we're going to put it. And we know our destination is going to be in this area right here, starting off at DS10. So, scroll down just a little bit. This is where we want our data to be, and this is where our data is currently located. So this is for loom number 1, and it starts off on DS20. Then you can see I've got the same information down here for loom number 2, starting off at DS40. And then DS60 for loom number 3, and of course DS80 for loom number 4. So the offset, the difference that I'm using between beginning of loom number 1 information and beginning of loom number 2 information is 20. So that's my offset. So what I want to do is take the loom number, multiply it by whatever my offset pointer is, and that becomes the beginning of my source location. For example, if I'm want to look at the information for loom number 1 times the offset pointer value of 20 is 20. That tells me I'm going to get this information beginning at DS20. And I'm going to get 5 informations. My destination location is always going to be DS10 for 5 consecutive words, 10, 11, 12, 13, and 14. I'm going to close this now. This is how I set it up first. And then I'm going to walk you through the program real quick. All right, back in the program, rung number 1, the first thing I do is I store a 10 into my destination pointer. Then I check to see what my loom number is, to see if it's the same as what it was before. If my loom number is not equal to my old loom number, then I want to pick up or energize control relay number 1, which says that I have a new loom number. Rung number 3, I copy the loom number into the old loom number, so now DS1 and DS2 are both the same. Then rung number 4, I'm taking whatever my loom number is and I'm multiplying it by my offset, which is 20. So now my offset pointer with loom number being number 1 is going to be 20. Then I start the for next loop. If I have a new loom number, that means I want to update my data from wherever the source is and bring it into my destination area so that it can be seen on the display. I'm going to bring over 5 words, so my loop is going to be 5. Rung number 6, I'm taking the value that's in DS20 because I know the DS3 value is 20, and I'm copying that, putting it into the destination file, which is DS10, because I know my DS4 value is 10. That's the pointer for that. Then I increment DS3 by 1 and increment DS4 by 1. So now my new pointers are going to be 21 and 11. And that gets me to the next statement, which says my for next loop is not complete. So it does 6, 7, and 8 again. Once it's complete, then I get to the end of my program. The reason I'm using a new loom here is because I don't want to be wasting scan time. Maybe my program will be a lot longer. I'm still trying to control 4 machines. So maybe my scan time becomes important. So I only want to do this when someone wants to see different data on the screen. So now let's take a look on the data view. I've set the data view up according to what the program is now. So you can see this is my control information, my loom number, the old loom number, my offset pointer value, and the destination value. My destination pointer is always going to be starting off at 10 for DS10. Now my loom number, if I put in a new value here, I change it to loom number 2. I double click on the right. Then you see the information here has changed. What is in loom number 2, which is 187, 2860, 72, efficiency of 91, and product code is 128. Those values are now in the display variables, the ones that we're going to be using to show on the display. So if the operator changes this now to a loom number 3, for example, now this values are changed to what was in from loom number 3, 464 yards total, RPM is 1750, shift downtime is 21, efficiency is 96%, and product code is 110. So the same thing if we go to a 4. Now the values have updated on our display from what we have down here in number 4. What happens if they put a number in that's outside of the range? So they put a number of 6 in, but we've only got 4 looms. It's going to address, source the information from, say, 6 times 20 is going to be 120. So 120 through 124 is where it's going to come from, which are all zeros. So because we've only got 4 looms in our real program, we would want to have something in here that limited the range of numbers 1, 2, 3, and 4 so that it agrees only with the actual number of machines that we have. Now something else too is these values here are just copied when we change. What if we wanted to look at the values dynamically? Say for example, we're looking at loom number 1 now. If I go to loom number 1 and I change the total yardage, for example, to 455. I write that in there. It's changed here on loom number 1, but it is not changed up here. The reason is we're only doing the update or transferring the data from our source to our destination only when there's a new loom number. So if I change this, for example, to from this, let's see, I make this one be SC1, always on. Now then, it's always going to be updating. So it wouldn't matter if I changed the loom number up here or not. It's whatever loom it is, it's going to be updating that data dynamically. Let me write this back down into the project real quick. So now if I go back into data view, you see now it's showing on number 1 is showing a 455. Let's say if I change this now to a 303, for example. Immediately that value changed to a 303. So this is dynamic. If the values are changing, I would be able to see the values changing if, let me shrink this down, if I make this happen all the time. Now, if I was not, didn't have anything to, well, let me take this back. If I went back to C1 right here, then if I did not have a new loom number, this is not going to operate. If I'm not doing the 4 next because this is not true, then nothing inside this is going to happen. The 4 in the next basically is one command. So when we come in and we don't initiate the command with the 4, it skips to the first rung after the command, which is the end. Let's take one more look at something else. If I look at the online project information, I see my current scan time is running about 4 milliseconds, with a minimum of 3, maximum of 5. And that's just for this. Now let's see what happens when we change it to running all the time. And I'm going to make a change on the program here. I'll go back to SC1, always on. Now I'll go back into the online project information and look at my scan times. Now my current scan times are about 7 milliseconds. So by doing this little section, continually over and over and over, it's like adding in these extra 3 rungs right here. So just give you a good idea of how everything works when you're using a for next, and also when you're using the pointer addressing. Well, I hope you've enjoyed this tutorial video number 8, where we did get into something that's a little bit more complicated than what we've been looking at before, but stick with it. I guarantee you there's still a lot more to learn. So if you're really liking these videos, don't forget to subscribe and give me a thumbs up.